Hey folks, it's Taras, and in today's video I want to go through a quick explanation of the coding project that I did for this site reliability engineering exercise that was by Fetch.com. Fetch.com does some e-commerce. I'm not really worried about the particulars, but that's where this SRE coding exercise comes from. And the exercise was to read in a file in YAML format. And YAML is just a data format that I'll show you in a minute. And this is going to have some REST endpoints. So basically, services that are provided by a website. And you're querying them to determine the uptime of the website and its REST API. And so a request is considered up if it has an HTTP result code in the range of 200 to 299. So those are the success result codes of the HTTP protocol, and less than 500 milliseconds of latency. And the idea here is to measure the reliability of a website. And once something's being measured, it can be improved. For example, you might improve it by investigating any networking problems in your data center, your back-end code, your database, things like that. All right, so let's dig into the code here, starting with the YAML file that they originally provided me. So here we see the REST API endpoints being defined. So a REST endpoint is going to have a header that's being passed to it, an HTTP method by which to call the endpoint, a name, so that's just an identifier, and then the URL that we're targeting. And then it can also have a body. So the body is really going to be passed as JSON data to something like a post request where the server is expecting to receive some sort of data. So yeah, that's the endpoints .yaml file that we're using as an input to our program. Interestingly, we also have this pylint.yaml, so I'll talk about this later. This is another example of a YAML file, but in this case, it configures our linter. And I'll talk more about that later. Okay, so let's take a look at our README. So with any coding project, you want to have a README that explains briefly what your program does, how to use it. And so here it is, and we can take a quick look at it in GitHub as well. So we'll go to our code section, and the README, it's a markdown file, and by default in any sort of GitHub project, that README file is going to get displayed. So it explains, okay, what the script does, how we install the dependencies here. Let's just check my Python version here. 3.12. And so you want to just be able to specify what the user needs to run your program, and that's what the pip install-r requirements is about. This is a text file in my project that enumerates all of the dependencies we can see here. And if you use -r on your pip install, that's the recursive option, and it'll go ahead and install all of our modules. So I used Python here because I wanted to learn a bit more about Python. And there is a nice PyYAML module that lets us conveniently read YAML data. So that's great. We've taken a look at our basics of how the input comes into our program. Next, you'll notice I'll have that in a data directory. Then I have a scripts directory and a test case directory, each containing this init and the PyCache. And the PyCache is built automatically by Python and Visual Studio. But these init files basically declare these folders as software packages that can be called in other spots. So this is just an empty file. I've seen it where it has some sort of text to to do a little bit of operations, but generally your logic is going to be outside of this init file, and it's just going to be blank. So let's take a look at our 3 domain files. Well, what I did originally when building these classes is I went for an object-oriented approach, and I realized that in a lot of cases that's not really necessary, because with an object-oriented approach you declare everything as a class, and then your class is going to have data and methods. But what I found was that a lot of my classes that I was building really didn't have that much data or methods. And in that case, I used the data class as well as some procedural programming where I was just declaring functions, procedures, rather than methods on a class. So we'll take a look at that. Here in our HTTP requests module, this defines just how we're requesting from these HTTP REST endpoints, right? And so I have this idea of an endpoint response, and this just defines some data and a couple of constants. The maximum allowed latency would be 499 milliseconds to get to our half a second target. It's basically too high if it's over 500 milliseconds. So that's our boundary condition, and so I just had some constants as well as a constructor to store data. And that's what the data class is for. You want that to just store some of basic data rather than building an entire class around it, just as best practice. Then we have our more proper HTTP requester, which has actual methods. Now, all of these methods are static. So I'm looking at this and thinking, hey, maybe this should still be just a bunch of functions. But it's not a bad idea to encapsulate our domain in a class even when everything is static, meaning there's no real object that it's operating on. Rather, it's just some methods that perform operations that don't necessarily modify the data state of the object. A couple things maybe that are interesting here is uses of a dict and a list. So the REST endpoints that we read in from our YAML file are going to be in a dict. And that's analogous to a hash table data structure. And the idea there is a really quick lookup time, so you can get data really fast provided you know what the key is. Whereas in a list data structure, it's hard to find data. You have to do some sort of search to find it, and that can go to O of n type of time, meaning you may have to iterate through the entire list to find the data you're looking for. But on the plus side, a list data structure is great for if you're generally going to be iterating over it in a loop. So that's the primary difference where you would use a dict as opposed to a list. A dict for quick lookup and a list for simple traversal. In this case, we're doing a query of endpoints, looking up the data of what to query from our dictionary, and then putting that into a list that gets output to our next stage of processing. One thing that I did note here is that the response.elapsed seems inaccurate. So in this case, I'm using the Python requests module to query these REST endpoints and report the result and the elapsed time in milliseconds. However, what I noticed is that it's measuring the results on my network, and just I've got a little bit of slowness. So when I'm running this, I'm consistently not even hitting a half a millisecond of latency, whereas when I was working on my laptop, I was getting much faster speeds. So there's just something going on either with this desktop or the network such that I get slower speeds. And that's why I'm not really sure that this method of determining the latency is really that accurate. So please, if you have any feedback on a better way to do this, maybe using Postman or something like that, I'm definitely open to hearing more about what's a good way to measure the latency of HTTP call. And is there a better way to do it in Python, or should I even be looking at using some other languages? This just supports wrapping the Python request module to query the result of an endpoint. And then we've also got get endpoint domain. So that just means, okay, you've got, fetch.com slash whatever, google.com slash whatever. Let's just get the domain out of there of fetch.com, google.com. And that lets us do analysis on the domain as a whole rather than, just these individual endpoints. How do you compile the results for the web domain as a whole? The endpoint reader. So here I really use that procedural programming approach because in this module, we've just got a single function and we don't really have any data that's being modified. So we're just reading the YAML file and serving up the endpoints. And then finally, the availability metrics. So the idea here is that we're going to support running the queries every 15 seconds. And then we want to have a continuous tally of the metrics of whether the website is up or down. We store a data structure of the availability dictionary that's mapping the domain name to a tuple storing the up count and the down count, how many times we measured the website is up versus how many we measured it as down, and then we can compute a percent uptime based on our results. So again, we're using a mix here of static and regular methods that actually operate on the object and the class itself. So this is a good example of using true proper object-oriented design pattern here in Python. That's the scripts. What I did when I built these is I built tests and I followed a test-driven design type of methodology. And in that test-driven design, you have a red-green refactor cycle. And what does that mean? You write a test that initially fails. You code your scripts to pass the tests, and then you go back and refactor and make your code better. And that's really how you do test-driven development. Really, to do that, you want to have a solid unit testing, a solid integration testing practice. So let's dig into that next with our unit tests over here. For each of the three domain modules in our scripts folder, I created a test case over here to do unit tests for it. There was a lot that I learned by doing this, especially about debugging as well as mocking. So that was really cool. We can take a look right here at this test endpoint reader. And in each case, I used the unit test as a base case for my tests. And I've worked with PyTest before, but unit test is just a lot simpler. It's the built-in default Python unit testing framework. One thing that's really nice is the integration here with Visual Studio. You can see this button you can click right here on the left in Visual Studio to run your tests. And also, I mentioned mocking, and mocking lets you inject a particular behavior into your test. So I wanted to test out what's going to happen with reading the REST endpoints from the YAML file when you run into file not found error or a YAML error where you'd fail to read the file because it's not valid YAML. Those are great questions, and that's where mocking really comes in. You can use this syntax here with mock.patch to pass in that error into your method and find out how it behaves. So That was really great. Let's take a look at some of these other tests here. The test HTTP requests. And in that case, I really created these mock endpoints, mock responses, and that allowed me to test what would happen, for various different types of REST responses. That was good. I also used this JSON placeholder.tibicode.com, and let's just take a quick look at that. This is just a really cool project that I found, I guess, by these mock-end folks that creates a fake API online. So we can just use this for testing, and I thought that was really useful. It's just a REST API with fake data, just a useful little software service out there. The final test case in here is the test availability metrics. And that just lets us test various edge conditions of endpoints being up, different latencies, the metrics as things are being measured. Using mocks and debugging and test cases, I think it's a really great practice, really great way to learn more about software development. That was excellent. Let me show you how these test cases actually get run, and that is in our README. You can run these at the command line. So the discover directive just is going to discover all the tests, and so it ran through all of our test cases. Or you can do a very specific test case like our test availability by calling that out with python-m unit test and then calling out that test library. So that's great. All my tests pass. Also, Visual Studio Code has some awesome integration for this. So you have to go down to this flash icon that gets you to your testing, and then you can go ahead, once they're discovered, go ahead and run these. And you can see how much this speeds up your workflow in terms of, okay, I have these 21 test cases that I'm running, and I don't have to remember how to do them manually. It's just anytime I make a change, I can just quickly run the test cases. It's a matter of seconds, and I can confirm, at least at a basic level, whether the software is doing what I intended to do. Test-driven development, it's fantastic. I'm a big advocate. The next thing I want to show you is pylint. What is pylint? Pylint is a linter or a static code analysis, static application security testing type of tool, which what that really means is that it's going to read your code and give you some metrics of the code quality. That can be liberating and frustrating because it helps you write better quality code, but it's frustrating because, it's going to block you. You want to have this high quality code and it's not at that standard, and then you're going to be blocked until you either say, hey, I'm just going to ignore this, or fix it up to the standard. And that can be really simple, like moving, import statements around. And that's kind of annoying and frustrating. But yeah, it just enforces the Python best practices in your code. And we have this pylint.yaml file. And what this does is it configures Pylint so it can be run locally, but we also have GitHub workflows. So what that means is that we have a workflow when we're committing our code to GitHub to run a Pylint check and analyze our code quality. And if it's not at quality, it can actually get rejected. So yeah, I spent a little while battling with that, trying to get my code to a good quality to be able to commit it successfully. So let's take a look at how that's actually run. I think I ran it not too long ago. So yeah, python-m pylint, and then fail under 9, which is a measure of code quality, and then we're doing ***, /star.py, meaning we're looking at all subdirectories here in our project and running this linter against all of the Python files. So let's give that a try here at the command line and see what that looks like. Okay, so there's a warning coming up for my to-do item where I noted the response elapsed is not accurate. And so with that little to-do, it's been rated as 9.96 out of 10, which passes our quality check of 9 out of 10. So let's say 90% ain't bad. It's a solid A minus. And that's the metric, but I did try to get it as close to 10 as possible. I do have that noted failure there with the to-do item. Okay, so let's take a look at actions. So this is what runs our pylint to analyze our code. So let's just dig into that. So when it runs with 3.9, 3.10, and 3.11 versions of Python. And I had mentioned before that I'm on 3.12, so really I should dig in and take another look at the versions. But yeah, there's just an automated process here on GitHub that goes through and checks the quality of our code. So that's tremendously valuable. So let's take a look here at how it actually calls pylint. Okay, pylint fail under 9, and then since we're doing a Linux server under the hood, there's this syntax to just do a git ls to find all the files. But when running it locally, I did that */star.py to accomplish that same result. And in this case, at the time, it rated my code at 10 out of 10, and that might be a difference between the Python and the pylint that's being run on my local laptop versus the server. Anyway, static code analysis and pylint is really cool. And yeah, it's part of the DevOps space, which I'll make some more videos on in the future. All right, so the final thing I wanted to show you guys is the main.py script. So where'd that go? All right, so the original exercise didn't really specify anything about pausing, resuming, or exiting. So the original design was just hit Control-C, but I did take a shot at using keyboard input to figure out whether the user wants to pause or resume or quit. But that didn't really work out quite as I expected to. Still, it's good. And our main script basically relies on our domain scripts to read the YAML file, loop through, and run metrics on the uptime and downtime of each REST endpoint, and then update that in the availability metrics data structure that is then reported to the user. So let's try that, see what it looks like. All right, just hitting that play button. So we've got 4 endpoints out of our data file. And like I said, there's just some network slowness on my PC. And because of that, we're going to hit 0% availability. It's not going to get that data within half a millisecond. One thing that is interesting to do here is to put in a breakpoint right there. Here's our metrics availability metrics. Oh, we don't have it running in debug, so we're not going to hit the breakpoint. That's okay. We can take a shot at pause and resume. Hitting that P button causes it to get paused. I'm going to try that space button to resume it. Nice. And then let's do escape to quit. Okay. Well, that escape button didn't actually hit our quit our program, so we're going to do a Control C to exit out. But yeah, I think that's enough code explanation. Uh, this was a fun project. I learned quite a bit. What's maybe my verdict here? You can tell that I was really enthusiastic about the automated testing as well as the continuous integration there with the pylint static code analysis tool. So I feel like I'm more of a dev and DevOps person than necessarily a SRE at this point. But I did have fun with it, the exercise, and I'm always curious to learn more, especially about the workings of a data center. So, yeah, I think that will be pretty much it for this video. Thanks so much for watching. I hope you found it informative. If you have any tips related to reading keyboard input or accurately measuring the uptime of a REST endpoint, I'm all ears. So please feel free to leave me a comment. Otherwise, hit like and subscribe. I appreciate you watching. Peace.